For generations, people have dreamed of ways to harness the power of the sun, to capture energy from the wind, to use water efficiently. Today, the construction industry is just beginning to incorporate these elements for long-term sustainability. Imagine building construction with tomorrow in mind, with concern for our planet and future generations. Today, the Southern Sandoval County Arroyo Flood Control Authority, or SCAFCA, has combined elements of conservation into a building expansion project with the highest levels of certified efficiency and compatibility with the environment. In early 2009, SCAFCA's Board of Directors not only approved the physical expansion of their facility, but challenged architects, engineers, and construction personnel to build a LEED certified facility. LEED, or Leadership in Energy and Environmental Design, is an internationally recognized third-party certification for green buildings.
It seemed to the board that if we were going to do a project like this, we ought to do it excellently, do it in a way that set the tone for other agencies and other institutions that might have to grow. So we looked at building a building that would symbolize many of the things we stand for. We stand for water conservation, energy conservation, utilization of the land with low water needs for landscaping and the like, preservation of water off the rooftops. And we thought, if we're going to do this, we ought to do it right, and we ought to do it well, and we ought to do it in a visionary fashion. Welcome everybody, I'm Mark Compling, I'm chairman of SCAFCA, and I'm here to welcome you to a luncheon and to a groundbreaking of the first, we believe, public building which will meet LEED certification for platinum.
With the commitment made to choose long-term sustainability over more inefficient construction, it was time to begin.
We're taking it very seriously. The board is very serious about it. There was a really wonderful conversation from the very beginning of whether or not this project was actually going to happen. Were we going to spend the money on this building or put it into other projects? I think we're at a great place because we've got the opportunity to make this building fantastic, showcase it to the community, and really set the stage for what construction has to be for the future. And that's what SCAFCA is about. Taking care of the future, stewardship, those are concepts that we believe in very seriously.
Choosing to build green is not an easy process. Many in the construction industry haven't experienced the strict standards to meet LEED certification. Understanding the differences and believing in the vision is vital to the project.
The platinum certification is the very highest level, and that's the one that we're shooting for. And that evaluation happens in 6 different ways. One has to do with a sustainable site. The other has to do with the use of water recapture, energy and atmosphere, the relationship overall, materials and resources that we may use, many recycled materials, indoor environmental air quality, and innovation in design.
LEED certification was developed by the U.S. Green Building Council a number of years ago, and it's essentially a process of benchmarking, setting a standard by which commercial buildings can be measured in terms of their sustainability, a sustainability index, if you will. In the simplest terms, for what we're talking about, sustainability has to do with the capacity to continue without the detriment of the future. Sustainability for me is a little bit more about making the best decisions that I can, the kind of decisions that don't have negative ramifications over time. And if we can make buildings more energy efficient, more non-toxic, and more integrated with their natural surroundings, that is a process which gets us closer to what true sustainability is all about.
With the focus on sustainability, the building site was prepared. Recycling containers were brought in. Waste materials such as rebar and wood scraps or the remnants from concrete pours would be recycled and not go to the local landfill as usually happens in construction projects.
You don't really think about it, you know, as you're going through the construction process. You don't necessarily see all that waste accumulated or the costs associated with it until it's all put into one place. You know, this would all ended up in a landfill somewhere if we hadn't recycled it.
Footings were poured, followed by the rest of the foundation, and the first major milestone in the construction process was complete. The west walls were backfilled to create an insulating earthen berm. Design specs called for additional space in the exterior wall construction to provide for greater insulation.
One of the things that we're doing with the building is building a wall that is so fantastically insulated to kind of coincide with a roof that's so fantastically insulated that our energy loss is actually minimized to the maximum degree that we can afford. So what we've got going on here is, and I don't know if you can see this with the camera, but offset dual wall, okay, with the framing, and essentially we have our load-bearing stud wall on the outside, and that's the exterior sheathing for structure. That's fairly conventional construction. By building this inner wall here, but offsetting the studs, when this wall gets insulated, the insulation will lay in here, essentially eliminating what's called thermal bridging. There's no way for the heat energy from the outside or the heat energy from the inside to pass through solid material. It has to pass through insulation, which is very good at resisting that flow. On top of that, we're actually going to have rigid foam on the inside and rigid foam on the outside, which is going to essentially encapsulate the wall and prevent thermal migration through the wall entirely. I mean, to a reasonable degree. But and then in some places around the building, we have this ICF wall construction, which many people are familiar with. It's a giant foam block that's core filled with concrete. It has about 2 1/4 to 2 1/2 inches of rigid foam on the outside and on the inside. This whole system is then bermed with earth behind it. So we have what we're shooting for here is a really bomber wall, but one that's also resisting the environment by virtue of isolation. It's buried in the dirt, which doesn't change that much, so the wall doesn't have to cope with a lot of fluctuations, and it's dealing with a relatively stable temperature year-round, which is overall more effective in the long run.
Also, an innovative rammed earth wall was constructed to equalize interior temperature and provide additional comfort.
The functional aspect of the rammed earth is to provide mass to the inside of the building as a kind of a thermal regulator for the building. The thermal mass of the earth, once it kind of reaches a stable temperature, will help regulate that. So temperature swings which result in human discomfort are minimized to begin with, having the net result of reducing the need for mechanical compensation. Yeah, basically a good analogy would be if you walk by a wall that's been sitting in the sun all day, you feel the heat radiating off of that, right? The same thing happens if that wall is cold or cool. Your own heat radiates to that cold body. So you actually get the sensation of cool, even though the air temperature may be warmer than what you would consider comfortable. You're comfortable by virtue of association with this mass.
As workers completed the framing, they moved inside, where design and function began to come together. Selection of materials and systems would make this a dramatically different building. Designing for maximum energy efficiency is still a fairly new concept in the construction industry, particularly for commercial buildings. As more green building takes place, making energy-efficient, sustainable choices will become common. The Skafka edition will provide an excellent case study for other commercial builders.
So the expansion of Skafka is doubling the size of the existing building, and which gives us a really good test case. So we'll be able to
We're independendly metering this portion of the building. We'll be able to track the energy usage of this side right next to that side. It's going to show, a really well-built building and an outstandingly built building performing side by side with each other.
As the interior space was constructed, no volatile chemical substances or materials were used. None of the traditional volatile organic compounds, or VOCs, will leach out into the workplace. The new Skafka addition also puts a high priority on water. Inside, low-flow plumbing will use very little water. Outside, water will be collected by channels in the native landscaping. Above-ground cisterns with a 16,000-gallon capacity will capture almost all runoff from the roof, piping that into the irrigation system. Another sustainable feature of the addition are the solar panels, freestanding structures that will also shade the staff's vehicles.
We're putting up enough solar panels here that will make this entire facility net zero, which means that it will, on hot sunny days, we will cool our cars, so when we get in them we won't have to use our air conditioners as much. It will pump plenty of energy in here and actually pump some back into the grid.
We talked for months about how to weigh costs with vision. And we decided that we should think of this addition as an investment rather than a cost. That we were taking the public money and investing it in a manner that reflected stewardship, that reflected savings over the years. So for example, we spent more on our photovoltaics so that we would be certain that the entire building's electricity needs would be met for the next 25 years. Knowing that all the while, electricity costs would be growing. So we invested against the growth of the cost of power.
I'm very proud of the board that they took a leadership role. I'm very happy with the architect that built us a structure that I think is just incredibly energy efficient.
This building was built to last, and it was built to endure, and it was built to be adaptable for this organization, which is a lasting organization. And this facility is going to operate and be nestled into this landscape for a very long time.
We need to move from simply cost controls and effective implementation of our mission to stewardship of the resources that we have. When we're given the public trust to spend money, it's not enough to just spend it. It has to also result in stewardship that saves energy for the public good. We can no longer use resources with abandon. We have to invest in ways of being good stewards of our resources.